Good morning, I am Renu Sharma, Assistant Professor, EC Department. Today I am going to start with Unit 5th, that is related to digital modulation techniques, that is ASK, FSK and PSK. So first we will discuss what is modulation. So modulation is adding the information to a carrier signal. So for modulation we require two signals. First one is the message signal, another is a carrier signal. So this is having frequency FM and this is having frequency FC. So FM should always be less than FC, that is the carrier frequency. Means higher frequency carrier signal is considered, and onto that carrier signal the information of the message signal is superimposed. So that is the main aim of modulation. So the sine wave on which the characteristics of the information signal are modulated is known as carrier signal. So this is converting the digital or analog information to a waveform that is suitable for transmission over a given medium. It involves varying some of the parameters of the carrier signal. So let's say there are three parameters, like first one is amplitude, second is frequency and phase. We can change any of the parameter, but the other two parameters should remain constant. Like say an example of ASK. So amplitude will be changed, but the phase and frequency of the signal is constant. So likewise for PSK and FSK is also the same case. So that is the general kind of sinusoidal waveform is given by this equation, that is A cos 2 pi fct plus phi. So if the information is digital, changing parameters is called keying. So that is amplitude shift keying, phase shift keying and frequency shift keying. This is the diagram of the modulation system. In this case you can see that the first block of this modulation system is a source. The output of this will be a source encoder, then channel encoder, modulator and a channel is there. So source is responsible for providing a signal, a continuous time signal that you want to modulate, that you want to transmit. Then it is passed through two types of encoder. First one is source encoder, another one is channel encoder. When it is passed through this, it will be passed through a modulator. Now modulator will basically going to combine the message signal information with the carrier signal so that it can be transmitted over a longer distance because the frequency of the signal will be increased. So then it is passed through a channel. A channel can be a wired channel or a wireless channel. Now at the receiver side there will be a demodulator, a channel decoder, source decoder and a destination. Now next is types of modulation. So there are two types of modulation that are used. First one is analog modulation, another one is digital modulation. So in this case analog modulation, if the variation in the parameter of the carrier is continuous in accordance to the input signal, then that is known as modulation, analog modulation. Whereas in case of digital modulation, if the variation is the parameter of the carrier is discrete, so that is known as digital modulation technique. So this is the diagram example of analog modulation, that is amplitude modulation and frequency modulation. In this case you can see that when the amplitude of the message signal is increasing, the amplitude of this will be increased and the amplitude will be decreased over here because amplitude is minimum of in this message signal. So that is the amplitude modulated signal. Next one is the frequency modulated. You can see that the frequency is quite increased over here, frequency is reduced here and frequency is increased again over here. So that is the case of frequency modulation. A digital modulation, in this case an analog carrier signal is modulated by a discrete signal. Digital modulation can be considered as digital to analog signal, and the corresponding demodulation is analog to digital converter. So that is the case of digital modulation where a D to A converter is used or A to D converter is also used. So in digital communication, the modulating wave consists of binary data and the carrier is nothing, it is the sinusoidal wave. So binary data is being converted into analog with the use of line coding. then this information will be superimposed on the sinusoidal carrier. It can be sine wave or a cosine wave. Now, this is the descriptive diagram of how this ASK FSK waveform will looks like. Now, first one is the baseband signal. This is the diagram of baseband signal. Now, this is converted to electrical signal with the use of line coding. So, you can see that 1 will be transmitted by a voltage, 0 will be transmitted using a 0 volt. Then a carrier signal is there which is of very high frequency compared to this signal, and it can be sinusoidal or cosine wave. Generally, we consider a cosine waveform. So, that is AC cos omega ct plus phi c. Next one is ASK signal. So, ASK signal is nothing, it is a kind of OOK signal, that is on off keying. Now, in this case, for bit 1 we have to transmit some amplitude, and for bit 0 we are transmitting literally nothing. It is shown with a waveform, but generally we are not transmitting any waveform for bit 0. Next one is FSK, that is frequency shift keying. So, in this case FSK, two frequencies are considered. For bit 1 higher frequency is used, for bit 0 lower frequency is used. Next one is PSK, that is phase shift keying. The phase of the pulse will be changed when the bit will change from 1 to 0 or 0 to 1, then the phase of the pulses will be changed. So, that is the case of PSK modulation technique. This is ASK in detail. So, in ASK the amplitude of the signal is changed in response to the information. So, you can see that over here for bit 1 you are transmitting an amplitude, and for bit 0 you are transmitting no amplitude signal. So, that is the case of ASK, that is amplitude shift keying. Now, this is some mathematical expression that we can consider for ASK to plot its spectrum. So, first we will see a carrier signal which is denoted by a formula, that is VCT is equals to cos omega CT, or in short it is known as it can be written as cos 2 pi FCT also, where 2 pi FCT is can be replaced by omega c. Then digital signal we will consider, that is unipolar in nature because we have considered only one amplitude, that is positive side. So, VDT will be is equals to, we are going to expand this cosine because it is a kind of periodic waveform. So, it can be expanded using Fourier series. So, that will be the formula. Then the ASK modulated signal is generated by simply multiplying these two signals, VCT multiplied by VDT. So, that will be equivalent to cos omega CT into 1 upon t plus 2 upon pi cos omega naught t minus 2 upon 3 pi cos omega 3 cos omega naught t. So, this is the expansion. Now, we have to use a property, that is cos A cos B is equals to cos A minus B plus cos A plus B whole divided by 2. So, after this we can consider this equation. So, next will be the FSK. In FSK we change the frequency response to the information. So, we require basically two types of frequency, one is higher frequency, another one is lower frequency. To transmit 1 we generally require higher frequency signal, and to transmit 0 we require a lesser frequency signal. So, this is FSK modulated signal, this is the digital signal, that is VDT is equals to modulated with omega 1, then V dash t is equals to 1 minus VDT, that is again modulated with omega 2 frequency. So, modulated signal is given by this equation, that is V FSK t is equals to cos omega 1 t into V naught VDT plus cos omega 2 t into 1 minus VDT. So, this will be the equation after simplifying. Next is this FSK waveform. Now, you can see that this is the waveform for VDT. For bit 1 you are considering this is unipolar again. So, you require two carrier signals, one is for transmitting bit 1 and the other is required for transmitting bit 0. So, this is the resulting waveform for FSK technique. Now, next comes the PSK, that is phase shift keying. So, phase of the carrier signal is varied to represent the binary bit 1 or 0. Peak amplitude and frequency remain constant during each bit interval. So, example of this will be binary 1 0 degree phase and for transmitting 0, you require a 180-degree phase shifted signal. So, Psk is equivalent to multiplying the carrier signal by +1 when the information is 1 and by -1 when the information is 0. So, St will be is equals to A cos omega Ct for binary 1 and A cos omega Ct plus pi for binary bit 0. So, demodulation is demodulator must determine the phase of the received sinusoid with respect to some reference phase. Advantage of Psk is it is less susceptible to noise to error than Ask, because we are just dealing with the phase. The maximum noise which is present in from 3 of the cases, that is Ask, Fsk, Psk, is in Ask only, because we are dealing with the amplitude variation, but in case of Psk and Fsk there is no amplitude variation, so the noise is very less. Disadvantage is that we require a more complex signal detection or recovery process than in Ask or Fsk. So, this is the diagram which is showing that how this phase change concept is there. So, we require a simple multiplier, the input signal is multiplied with the oscillator and we are having the phase shifted signal, that is frequency phase shift keying, and this is the waveform that is related to Psk. So, this is the Psk detection. So, multiplying the received signal again with the carrier signal. So, it leads to a component that is cos square omega Ct. So, the resulting signal for bit 1 it is A 1 plus cos 4 pi Fct, and for bit 0 it is minus A, in bracket it will be 1 plus cos 4 pi Fct, this one. So, these are the two higher frequency components which are present, and that will be filtered out with a low pass filter. So, the output will be contains only low frequency component signal. That is how we can detect the Psk waveform. Next is facts from the modulation theory. So, if the bandpass channel having width W hertz, then the baseband channel has WC by 2 hertz, that is available. So, it supports maximum system supports WC pulses per second. Now, next one is the Qpsk. So, Qpsk is basically quadrature phase shift keying, where we are considering this concept where 2 bits are combined together and 4 phases are decided: 0 degree, 90 degree, 180 and 270 degree. So, whenever the bits input bits are 0 0, then that will be mapped to 0 degree, means no change in the carrier signal pulse is there. In case of 0 1, 90 degree phase shift will be there, the carrier signal 1 0 180 degree and 1 1 it will be 270 degree. So, this is how we can draw a Qpsk waveform, that is also known as 4Psk waveform. The last topic is QAM, that is quadrature amplitude modulation. In this the same concept is used, but we are using two channels, that is in phase and quadrature phase channel. So, in this the original information stream is split into two sequences that consist of odd and even symbols. So, this is how the bits are being splitted. So, AK sequence is modulated by cos omega Ct and BK sequence is modulated by sin omega Ct. The composite of this will make up a transmitted signal, that is AK and BK. Advantage of this will be data rate is equals to 2 bits per bit interval. This is the waveform related to QAM, and this is how we can demodulate the QAM signal, that is by multiplying the Yt by a locally generated carrier, that is cos omega Ct 2 cos omega Ct, and this is in phase channel, this is quadrature phase channel again, and we can get the two components AK and BK. So, this is all about today's lecture. Thank you.